Hi everyone! In this video we're going to look at redox reactions and how they relate to the process of cellular respiration. When we move electrons around from one molecule to another, we're performing reduction and oxidation, or redox reactions. These two always go together because for something to be reduced or gain electrons, something else has to be oxidized or lose electrons. To remember which is which, I was always taught the mnemonic oil rig. Oxidation is loss, reduction is gain. During this transfer, electrons will lose potential energy, and the amount that an electron has within a molecule relates to what type of atom it's a part of. Electrons associated with less electronegative atoms, like those in carbon-hydrogen bonds, for example, have higher potential energy than those associated with more electronegative atoms, like oxygen. This is important in cellular respiration when electrons are moved from a complex molecule like glucose, where they have high amounts of stored potential energy, to oxygen, where most of the potential energy will have been released and can be harnessed by the cell. As we mentioned, the thing that's moving from one atom to another during redox reactions is an electron. In this example, an electron will move from atom A to atom B. This will result in atom A being oxidized, because remember, oxidation is loss, and atom B being reduced, because reduction is gain. We can also refer to the oxidized atom as the reducing agent, because it reduced the other. And we can refer to the reduced atom as the oxidizing agent, because it did the oxidizing. In the overall process of cellular respiration, glucose, the purple hexagon here, will be oxidized, and ultimately oxygen will be reduced, when it accepts electrons from the glucose, forming water. Unfortunately for a cell, the reduction of oxygen to water in this way is akin to igniting rocket fuel, and will cause the cell to explode if done in a single step. So, we have to have a more controlled way to release the energy in stages without blowing the cell up. This is where electron carriers come in. These are molecules that can pick up electrons and help to move them through the stages of cellular respiration so that the cell can harness the energy from them in a controlled manner. The main electron carrier in cellular respiration is nicotinamide adenine dinucleotide, or NAD, which exists in either an oxidized form as NAD+, as shown here, or a reduced form as NADH. You can think of this molecule as kind of a box for electrons, with NAD+ being an empty box and NADH being a full box with 2 electrons in it. If we take 2 of the electrons from our glucose, we can hand them off to NAD+, making glucose our reducing agent and NAD+ our oxidizing agent. Those electrons will travel with the remaining hydrogen ions from the bonds they were participating in, one of which will combine with the NAD+ and electrons to make NADH, and the other being released as a hydrogen ion. The glucose will then have been oxidized into 2 molecules of pyruvate, and this is effectively what happens during glycolysis, the first stage of cellular respiration, which we'll look at in more detail in another video. Thanks for watching, and please make sure to check out the other videos on the different stages of cellular respiration.